Assalamu alaikum. Now let's start with subtopic 7.3 lenses. The concave or a concave lens is thinner or thicker at the center, and it's diverge or converge light. Actually, the concave is thinner at the middle, and it diverges the light. So the answer is A. This is this is how we draw the concave lens. The convex lens is like something like this. Now we will solve an example on it, but I wanted to show you the difference between them. So the convex, which is this one, will be thicker at the middle and it's converge light. Okay. Now let's look at this question. The diagram shows rays of light passing through a converging lens. Converging lens, of course, we mean convex. Convex lens, it's the same. Converging is convex. Which labeled arrow represent the focal length. The focal length of the lens is the distance between the lens and the focal point. Where is the focal point? This is the focal point where the light converged, right? So this distance will be the focal length. So that represented by D. So the answer is D. Now, which length is the focal length in this angle? Good. In this lens. Here, it is a tricky question actually, because some students will see, oh, the light is converged here, so it is the focal point. That is not right. The focal point should be on the principal axis. This is the principal axis, so the focal point should be there. Now, which light will go to the focal point? Actually, the parallel light. The parallel light ray will refract to the focal point. So this is the focal point. This is a tricky question. We need to be careful. So not here. This is not right, because the focal point converges the light coming from infinity. So the parallel light will be converged in the focal point. So here we have only one parallel ray, parallel to the principal axis. This is the principal axis. Okay, so this light ray is parallel. The red one is parallel. Okay, I will draw it again. Let's give it green color. This light ray is parallel, and now it will refract to the point, focal point. Now, where is the focal length? Focal length is B, the distance between the lens and the focal point. So the answer is B. Next question is actually I know that you worried about this type of questions. Actually, don't worry, it's easy. Just we need to understand three rays. That's it. First one is how to draw. The question is how to draw the image. First one is the parallel. We take light parallel. First of all, we start our drawing from the top of the object. We choose one point to draw all the rays. we draw all the rays from one point. This is one of the common mistake. Some students draw something like this and then like this. That is not right. All rays should start from one point, which is the top of the object. Now, first we draw a parallel light ray parallel to the axis, the principal axis. Is this lens convex or concave? Actually, it is convex because it's thicker from the middle. Since it's convex, we need to understand that we use the focal length in the other side of the object. What do I mean? I mean this parallel ray will refract to the focal length, to the focal point, to the focal point. طيب, what is the other ray we draw? The other ray number 2 is the ray that goes from the midpoint. This is the midpoint. This ray is very important. This ray will not refract, actually will continue as it is. Okay, so now we have two rays. One is parallel, will go to the focal point. One is going from the midpoint, it will continue straight. Third one is coming from the, let's choose another color. But let's take the blue. Coming from the focal point to the mirror, and that one will refract parallel. Okay, so those three rays will they will meet at this point. So this will be the top of the image, and clearly the image is inverted because it's upside down, so it's inverted. It's real because it's in the other side of the object, the object on the left, the image on the right, so it is real. All same size, you can count here, 1, 2 units. The height is 2. The height of the image also 2. That's it. It's that easy. Here, let's also deal with this one. This one has a small difference, that the object is between the focal point and the mirror. But no problem at all, because you will inshallah solve it. Again, we have one parallel light, and this parallel light will refract into the focal point. Now also we have the mid point will continue. Let's choose same colors as we used to choose for the mid point ray that continues the same. Now here, if we want to draw the light coming from the focal point, if you remember here, the light came from the object to the focal point, then to the mirror. طيب, for this case, we can't do that. But again, we need it coming from the focal point. So the light will be like this. The blue one. Look at the blue one. It's coming from the focal point. Oh, yes. It looks like it's coming from the focal point. واضح, clear? So it's coming from the focal point. At the end, for the mirror, it's coming from the focal point. So the light coming from the focal point refract parallel. Don't forget, refract parallel. شايفين the blue one refracted parallel. Here also the blue one refracted parallel. طبعا when you look at this drawing, you will find that those rays will never meet. Those rays will never meet each other. So in this case, we look at the origin of it, where it's coming from. Let's look at this one. Okay, we now draw them back. Okay, this one is coming from this point, also the midpoint ray, so they meet at this point. In this case, since the image and the object in the same side, it's virtual image, and as you can see, it's upright and enlarged. It's bigger than the object itself. Okay, now I will answer this question, but first let's look at this drawing. We have the convex. When we have convex lens, let's look at them. This is the object, okay? This is the object. Now, the parallel light, again, if you remember in the in the convex lens, we said that we will use the focal point on the right or on the other side of the object. Now we will use the focal length in the same side, the focal point in the same side of the object. What do I mean? The parallel light will refract not toward the focal length. No, it will refract as it's coming from the focal length, as you can see clearly, right? It is coming as it is coming from the focal length, the focal point, I'm sorry. Okay, now let's look at this one. This ray is as it is going to the focal point of the other side, and this will refract parallel. Again, we take the origin. Last one, the middle, it will not refract. So as you can see, they all meet at this point. So the image is virtual because it's in the same side of the object. It's upright and it's smaller in size, or we can say diminished. Okay, now let's look at this equation. Actually, always for the concave, the image will have same properties. It's virtual, smaller, and upright. So yes, the answer is D. And for this question, an object of height 2 centimeter is placed 15 centimeter from converging, that means convex, converging lens of focal length 5 centimeter. What is the image distance? Actually, we say 1 over f, this is the formula, 1 over f equal 1 over q plus 1 over b. Let me check what are the letters used in the formula sheet, because yes, b and q. B for real, for the object, I'm sorry, and q is for the image. B, the distance between the mirror and the object, and the q is the distance between the between the mirror and the image. Of course, f is the focal length. Now, the focal length is 5 centimeter, but here, since it's converging lens, it will take it positive, 5 centimeter, 5 positive. If it's diverge lens or concave, we will take the focal length as negative. Be careful to this point. Okay, that's equal 1 over 15 or 1 over q plus 1 over 15. So 1 over q equal 1 over 5 minus 1 over 15. 1 over q equal it will be 15 2 over 15. So q equal 15 over 2. Q equal 7.5 centimeter. This is the distance, the distance between the image and the mirror. Before ending the video, I want to write something here. For convex mirror, F is positive. For concave, F is negative. This is very important to understand. Thank you for